Okay, morning once more. Today we are going to have a lesson on science and technology. Samantha, you can take that down. Today we are having a lesson on science and technology. We are going to continue on energy and fuels. This is our last topic on energy and fuels. This is our last topic on energy and fuels. The last time we talked about energy, we talked about two types of energy, which was hydroelectrical power, hydro energy, and thermal energy. Still remember, Samantha?
Yes.
Yes. What did we say hydro energy comes from? Where does it come from? Hydro energy. Where does it come from, Samantha?
Kariba.
From Kariba, yes, it comes from Kariba. That is our source because Kariba has water, okay? Hydro means water. And what about thermal energy? Where does it come from? Thermal energy. Where does it come from? I want the place. The place. It starts with an H.
Wange.
Wange, yes, it starts from Wange because Wange is the place where we get cold. Thermal energy is from, remember we said our energy comes from fuels, and thermal energy comes from coal, which is good. I can now see you, Charmaine. I hope you can hear clearly, Charmaine. Good. Okay, we are having our recap. We said hydroelectric comes from water and our source is Kariba Dam. While thermal energy comes from Wange and the source for the fuel is coal. Today we are going to look at electric energy. We're going to look at electrical energy. Electrical energy. We are wrapping up. It's our last topic on energy and fuels. We're going to learn about electrical energy. Let's take down some notes. Electricity is a form of energy. Electricity is a form of energy. Electricity is a form of energy. Welcome, Shadrach. Can you hear me? I can see you up to the nose. Okay? I want to see your full face. Yeah, that's better. Please position your device well. Okay, can you hear me, Shadrach? Shadrach, can you hear me?
Yes, ma'am.
Good. We are having a science and technology lesson on energy and fuels. Today we are learning about electrical energy. Take that down. Electrical energy. We were saying that electricity is a form of energy. Okay, electricity is a form of energy. In Zimbabwe, the main company that gives us electrical energy is ZESA. Who can tell me what ZESA stands for? What does ZESA stand for? We always say, yes, ZESA has taken the electricity. What does ZESA stand for? At our level, you can be asked what ZESA stands for. You must know the parastatal that is responsible for distributing electricity to the rest of the country. ZESA stands for ZESA stands for Zimbabwe Zimbabwean electricity distribution. Sorry, Zimbabwean Electrical Supply Authority. Zimbabwean Electrical Supply Authority. That's ZESA. It has many names. Sometimes it's ZESA. Then there's also ZEDIC. I'm sure you've seen their tractors. Zimbabwean Electrical Supply Authority. That is ZESA. Zimbabwean Z, Electrical E, Supply S, Authority A. That is ZESA. We call it ZESA. You hear someone saying the ZESA in South Africa is gone. That is wrong because ZESA is only from Zimbabwe, okay? Zimbabwean Electrical Supply Authority. ZESA is responsible for distributing electrical energy to all Zimbabweans all over the country. That is the biggest parastatal. We call it a parastatal. It is the parastatal that distributes electricity to the rest of the country. Okay, we cannot see electrical energy, but we see what we cannot see the electrical energy, but we see what it does. Who can tell me what does electrical energy do in your house? What does it do in your house? What does electrical energy do in your house? Anyone who can tell me? Yes, Shadrach?
It makes things work.
It makes things work.
Like
which things?
Like refrigerators and television.
Good. Thank you, Shadrach. That was good. It makes things work, and these things are the refrigerator. Remember, the refrigerator, the moment the electrical energy is out, it is also out. That's a good example. The television set as well. The television set is also out. Television set as well. The television set as well. Okay. Even the stove as well. The stove, it is, we see what the electricity does when you see the stove is on and it's hot, which means that the electricity is there. Unless, remember, people are now using solar stoves, others are now using the gas stoves, but we're talking about that stove that you use that is connected to the ZESA. Yes. Okay. Electricity is possible because of charges. Now we are starting, I'm going to start telling you about these charges. I want to ask yourself, how does this electricity work? Where does it come? What happens? The last time we talked about hydroelectrical energy, we talked about the things and all that. Now, say that charges. Electricity is possible because of charges. Charges is CHARGES. 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 We want to talk about these charges. What are these charges called? So for electrical energy to be there, there should be some charges there. There are two types. Let's write the subtopic. Types of charges. Types of charges. We have two types of charges. We have the positive charge, which is shown by the plus sign, the positive charge. We have the positive charge, that is the plus sign, and we have the negative charge, which is the minus sign. Okay, we have a positive charge and a negative charge. Okay. Is there anyone of us who knows a dry cell, or we call it a battery? Do we all know these batteries? This type of a battery, this one? Do we all know it? Where does it work? This type of a battery. Where does it usually work? This type of a battery. Where do you usually put it? This type of a battery? Yes, Charmaine? Charmaine is a bit... Sorry, yes, Charmaine?
On the remote.
In the remotes, yes, good. Anywhere else where you put this type of a battery? Yes, Shadrach? Yes, in the torchlight. Anyone else who knows where we put this? Anywhere else where we didn't mention? Yes. So I want us to take a look at this battery today. We want to talk about how electrical energy is made through this battery. This battery has two sides, okay? This is the side, which is the positive side, and It is
Yes.
the side, don't it? This is what these are what we call charges. Okay, electrical energy is made possible by the two charges. It is the positive charge, the positive charge, and the negative charge. Is the positive charge and the negative charge. So when I say the two types of charges, I was talking about this battery. The positive one is this one, and the negative one is at the back. Have you ever noticed these two charges when you have a battery?
Yes.
Have you ever seen them?
Yes.
Yes. So this, the pointed side is the positive charge. And then the back side, the flat side is the negative charge. When you put into the remote, usually when you are placing it into the remote, right, you have to place it properly so that the positive charge has to be connected to a negative charge in the remote. So that as you are placing the two, when you are placing the battery into the remote, you have to place the positive and the negative, they attract. When they attract, they cause a spark, and that spark is the electrical energy that makes your remote or your torchlight to light. Do you understand?
Yes.
Yes, that is what happens.
Yes.
As you are placing the battery into the remote, okay, place it in a way that the goes with the negative, and when the two meet, they spark to create electrical energy, which is the electricity that we talk about. And even we are going to talk more about the circuits later on. For today, we want someone who is making noise at the background there. Please, okay, I think it's now okay. Okay, are you all able to hear me?
Yes.
Yes. So we were saying that electricity,
Yes.
okay, good. Electrical energy is, we say that it is possible because of those charges, okay? For the electricity to be there, the two charges, the positive must meet the negative for them to spark an energy, and the electrical energy is formed. That is how you are able to switch on your torch. That is how you are able to switch on the TV using the remote. Okay, that is how it works. That is how the electrical energy is made. Okay, yes. And then now I want to go, how does electricity get formed? We say electricity gets formed when the positive, right? The positive and the negative attract each other. Maybe a question can come, they can come and ask you, when there is a dry cell, we call this cell a dry cell, okay? In science, we call it a dry cell, the battery.
Okay.
Yes. In English, you call it a battery. In science, you might find them calling it a dry cell. A dry cell is a battery, okay? You can say, how is electricity generated or created in a dry cell? You say that the positive meets the negative, and together they create electrical energy. Okay, that's how it happens. Okay, are we together there? Okay, yes. Shadrach talked about a torch.
Yes.
How a torch works on the electrical energy. What happens is a torch works on the electrical current. There is something called an electrical current. Let's write it as a subheading. Electrical current or an electric current. Okay, an electric current. We want to talk about how does a torch get to light using the dry cell. So I want to talk about an electric current.
Teacher, can you please spell the word current?
Or current, sorry, C-U-R-R, C-U-R-R-E, C-U-R-R-E-N-T. That's the spelling.
Yes.
You might be asked in a question, in an exam, what is an electric current? An electric current is the movement of electricity. Okay, electric current is the movement of electricity. When the positive and the negative attract, they create an electric current. Okay, An electric current is that spark that is there, that is created, that's moving. It starts moving, okay? It starts moving within the cell to create the electricity. I hope you are able to understand me. If you are not, please, you are allowed to ask, okay? Because we are doing it in stages so that you are able to understand. Are we together?
Yes.
Jacqueline, are we together?
Yes.
Yes.
Okay, so we said this is how a torch works. You put the batteries, right? The positive part. When you put it where you remember inside the remote there is a string thing like that you usually put, and then you push the negative towards the back. Have you ever noticed that when you put the batteries? There will be a
Yes.
string
Yes.
part in the remote there. Yes.
Yes.
Part the remote will be positive for the remote. And then you push your battery, you push the negative part of the back part of the battery, the flat one, towards the string. Okay? Yes. So as you're pushing it, you are making the negative of the battery. It connects to that string, the positive part of the remote. An electric current is created, which is the electric energy. It moves, starts moving, and then you are able to light your torch, whether it's a torch or whether it's a remote. Do you see how it happens? It's not magic. Somehow, there is a positive and a negative, the charges that we talked about, they have to attract together and they create an electric current, which is the movement of electricity. Then electricity starts moving and the torch, voila, it's on. You understand? That's how it becomes
Yes.
on, and that's how you are able to light your way or
Yes.
whatever you're looking for in the dark. Okay, so we are still on electric current. I said electric current is the movement of electricity. I wanted to firstly explain, okay? Then we take down the notes as well. We are explaining so that we understand what we are talking about. Then inside the dry cell and electric current, inside the dry cell, an electric current is produced. You see, we say the dry cell is the battery. Remember that. Science, they might not call it a battery. What is a dry cell? And now you wonder, it's just a battery. Okay. So inside the dry cell, an electric current is produced. Another sentence to write under the electric current. When a dry cell is connected to a lamp or a bulb, when a dry cell is connected, when
Teacher, I can't hear.
can you hear
I
me?
can't hear.
No.
When a dry cell is connected to a lamp or a bulb, yes, when it's connected to a lamp or bulb, okay, we have the electric current starts flowing. It flows. The electric current flows through the wires of the lamp. Current flows through the wires of the lamp or the bulb. So this is how electricity is made, okay? You place the battery, right? And maybe the battery is connected to a bulb or a lamp, right? When you place your battery there, what happens is the positive and the negative, they spark and then they create an electric current which starts flowing through the wires until it gets to the bulb, and the bulb becomes on. That's how the bulb gets to be on. Now we are doing it when we are using the dry cell. We are going to look into the next part. We're going to look at when we are doing when you are putting it on a switch. Okay, so now we are looking at the dry cell. The next time we're going to look at the switch. So today we're just looking at the battery side only. Okay.
Yes.
I want to tell you about a dry cell. What does a dry cell have inside? This is the picture of a dry cell, right? This is a dry cell.
Yes.
A dry cell, we said, is a battery, right? A battery has outside, it has a zinc can. Have you seen that if your young sister or your young brother removes the paper of the battery, it is silver inside. Have you seen that? Who has seen that it is silver? The battery is silver.
Yes.
Seen it?
Yes.
The battery is silver. It is a
Yes.
zinc can. That silverness is called a zinc can. That can is zinc, right? And inside the battery, your mother always says, don't chew that battery. Why? Because the battery has a chemical paste or a jelly inside, right? It has a chemical paste or a jelly that is inside here. The paste, how does it happen? This paste, right, if you put the battery into the torch, this paste will react with that zinc outside thing, that silver part, and as it reacts with this silver part, it will release what we call electrons. These electrons are the electricity currents, okay? It will create some things called the electrons. These are the ones that are transmitted into electricity. So the battery itself inside has a paste, a dry paste or jelly that is inside. That's why your mother always says, don't chew. Your young babies love to chew the battery. And they say it's very dangerous to chew the battery. Have you ever heard them say that? Because it contains a chemical paste or a jelly inside.
Yes.
Jelly is the one that attracts to the silver zinc and it creates electricity. So don't ever eat that chemical because it's a chemical that is inside. If anyone eats that chemical, you might react to it because that chemical it's a chemical paste that is created in the industries. That's the one that enables us to create electrons which make the flow of electricity. Okay. This is what I said inside. Don't worry, I'm going to take the pictures for this and I'm going to send for you so that you are also able to read on your own. Okay. I'm taking the pictures so that you are also able to read. I'll take pictures for you so that you are able to read. Okay. Yes. So that you are able to read more before you answer the questions. Okay. So the flow of the electrons is called direct current. So the flow of this electricity will flow. Remember, we said electricity will flow when it has been created by the cell. It will flow and convert from chemical energy. We said paste is a chemical, right? It changes from chemical energy into electrical energy. That's how the torch gets to light. We talked about that energy can be converted from one type to another. So it is converted from chemical energy, which is this black paste that is in here, converted into electrical energy. This is how electricity is generated when you put that battery or the dry cell into a torch. Okay. This is how electrical energy is generated. Okay. When we are using a torch, this is how you light your torch shut. After this, you can also go and try and do it and look at the positive and the negative. Some batteries have a positive, a plus, and a minus at the as you are putting the battery, if you don't have a torch, you can use the remote at home. You can just borrow it and then you see, you place your battery there. You'll notice that the positive will go to the negative side. They will create a spark, which is the one that generates. This is what happens because the battery inside is the chemical paste that converts from chemical energy into electrical energy. Okay, yes. Now I want to talk about the types of electrical energy. The types of electrical energy. We are going to the end of our lesson. The types of electrical energy. Types of electrical energy. This type is called static electricity. Static, S-T-A-T-I-C.
I can't hear.
You cannot hear me?
Yes.
What about now? Can you hear me now?
Yes.
Okay. I said there are two types of electricity. The first one is called static electricity. Static with S-T-A-T-I-C. S-T-A-T-I-C. S-T-A-T-I-C electricity. This electricity, we're going to learn it in grade 7, but the one that we're going to learn about now is current electricity. Current, C-U-R-R-E-N-T, C-U-R-R-E-N-T, current electricity, C-U-R-R-E-N-T. current electricity. Current electricity is electricity that moves through conductors. Current electricity is electricity that moves through conductors. Current electricity is electricity that moves through conductors. It moves through conductors. A conductor is any metal that allows electricity to pass through. That's what a conductor is. A conductor is any object that allows electricity to pass through, like a metal. Things that are metal allow electricity to pass through. Have you ever seen those Zesa lines? Those Zesa lines that you find on top that are high up, they are made out of metal. Have you ever noticed that?
Yes.
Yes, those ones that you are told that you must not touch. Usually naughty boys will throw their tennis shoes on top, and then their tennis shoes are hooked on top of those wires. Have you ever seen that? They usually do that. Those Zesa lines, you must not do that because they are very, very dangerous. They are made of condensed, those are conductors, they are made of metal, okay? So today we learned about electrical energy that is transmitted through a torch, okay? We say that we use we use to transmit or to generate electricity through the zinc and this chemical jelly that it has inside. That zinc and chemical jelly will attract and then they will generate electrons which will form an electric current, which will move electricity. It will move electricity and you are able to light your torch, okay? And we also learned about current electricity. We're going to continue our lesson next week on Monday when we are continuing and talking about current electricity, where we're talking about switches, we're talking about how to light things and how to connect, how you light your refrigerator on a switch, okay? I hope you managed to do today's lesson. Nice weekend. I hope it worked for you. Science and technology, okay? In relation to what we covered through from the start up to the end. We are still going to continue more, okay?
Yes.
Okay, so let me give you a chance to say goodbye to one another before
Okay.
we end our lesson for today.
Bye, Samantha. Bye, Charmaine. Bye, teacher.
Bye,
Bye,
Shad.
Bye,
Bye,
Samantha.
Samantha.
Bye, Samantha. Bye, Shadrach.
Have a nice day.
Bye, teacher.
Don't forget to submit work, Shadrach. Please tell your father to
Bye.
invitation, okay? Accept my invitation
Okay.
from Nancy Jackie, okay?
Yes.
Okay, have a nice day. Bye, guys.
Bye.
Bye.
Bye, teacher.
Bye, Shadrach.
Bye, teacher.
Bye, Samantha.